Okay, we have two rational expressions, okay? A fractional expression with some, some symbolic expressions, and a symbolic fractional expression here. Those are called rational expressions, okay? And the thing we want to see here is just common denominator is C times A plus B. Okay? Because that's how we add expressions that have denominators and find a common denominator. So we write this as follows: B squared times A plus B over C. And we're going to multiply that by something over something. That's going to be plus A over A plus B multiplied by something over something, right? That's how we add fractions, okay?
Okay.
So what we want to get is we want to get the same denominator, right? And the denominator has to be this times this, okay? So what would we multiply by here in order to make the denominator into this?
C.
Again?
C.
No, we've already got C here. If we multiply by C over C, we're going to end up with C squared, right?
1.
We want the denominator to be this.
Right. So,
Okay. So we have to multiply by A plus B over A plus B. I'll put parentheses around those A plus B's because it's kind of a good idea.
Okay.
And now our denominator is going to be C times A plus B. Okay?
Okay.
Over here, what would we multiply by?
C.
Well, C divided by C, right? Because we can't just multiply you can't just multiply by C, we multiply by 1. Well, C over C is 1. Now that's, I think, what you meant.
Yeah.
But you want to be very careful about that, okay?
Yeah, okay.
Okay? So now you have B squared times A plus B times A plus B over C times A plus B, right?
Right.
And then that's plus A times C is just AC. And better put parentheses around that so we don't mess up. But we definitely need them down here, whether we put them here or not. Okay? Not strictly required here, but they are required down here because you're going to multiply that by C. Okay?
Right. Okay.
And now the denominators match, but by commutativity. So that's equal to B squared times A plus B times A plus B plus AC, all that divided by C times A plus B. Okay?
Okay.
Now that's a big mess. I don't know what it means. I don't have an interpretation in mind. Okay?
Yeah, okay.
But I do know that the symbols have to do what they just did because those are the rules. The only way I can add two expressions is if they have the same denominator.
Okay.
Okay? The common denominator would include both this denominator and this denominator. The smallest denominator that includes both of these, right?
Right.
And that would just be this. Okay? In order to make this denominator, which is just C, into this, I have to multiply by A plus B, right?
Right.
So I multiply the denominator by A plus B, but that alone would change the value of the expression. But if I put an A plus B on top, it doesn't change the value of the expression because now that's just 1, right?
Right.
So this expression times 1 has the same value that this one did. I didn't change the value of the expression. Okay?
Okay.
And then over here, again, to get the denominator, I've got A plus B already. I've got to multiply that by C in order to get the same denominator I ended up with here. So multiply by 1 in the form of C over C. Then I just do the arithmetic. That's very simple. I mean, just multiply denominators, multiply numerators, I get this, still have the plus there, right?
Right.
But now the denominators are the same, so I can add the numerators. Now, there might be cases where this simplifies and factors in such a way that something divides out.
Mm-hmm.
But in this case, it doesn't, and we're not going to worry about that just yet,
Okay.
because that gets a little more complicated, okay? We just want to get the idea that the operations that we do when we multiply fractions are the same with numbers or symbols.
Okay.
Just looks different and
Yeah.
gets a little uglier when we got symbols sometimes.
Yeah.
Okay? But then you don't have to worry about the numbers, you just have the symbols. Some
Mhm.
ways that's simpler.
Yeah.